Okay, so this tutorial would be about the Gauss-Jacobi method on Excel. So let us first show the given. So now, let me explain this code. What this code does is it compares if C3, the absolute value of C3, which is in the X column, is greater than or equal to the absolute value of D3 plus the absolute value of E3. And if that is true, that is greater than or equal to the sum of the two, then what would show in this cell here is C3. C3 would be 4. But in this case, that's not true, since 4 is not greater than or equal to the absolute value sum of these two here. So let's check if the other rows have a X dominant element, a more X dominant element. So let's paste the code again, this code here. So now what we would change is just the value of the cells, or rather the designations. So what we would compare now is the X value in C4 compared to the sum of the absolute value of D4 and E4. So, and now what if this is true, this statement is true, then what should show here on this cell? Again, we're done with equation 1 already. What we're comparing now is equation 2. So if this is true, then what should show is the X dominant of the second row, second equation, which should be C4. So in this case, we can see that the second equation is the X dominant among the other equations. But what if the arrangement was different? Let's say it was on the third. So let's not leave the third line. Let's put a third line of code to compare, to see if the third line, the third equation, has an X dominant element. So let's just change the values here to C5, since C5 is the one with the third equation, and D5, E5. Then C5 should show. And now let's close the equation. Just keep putting close parentheses until the color turns black, and then if I press enter, it should show in this cell here that the value should be 19, since this has the X dominant element among the three equations. So let's see. Okay, there we go. Now since this is the second equation, the second equation is now up here, the other elements should also follow, which in Y would be -13, Z 4, and the constant 111. So how do we do that? Let's copy the code in this cell we've made. Let's copy the code we've made before in this cell, and let's paste it here in the Y cell. So what we would just change right here is the output. So instead of this C3, C4, C5, what we would want to show is the Y element. So in this case, if C3 is the absolute value of C3 is greater than or equal to the absolute value of D3 versus E3 is true, then we should show in this element here the element y of the first equation. So that would be D3. And then the rest should follow. If this is true, then this output here should be D4. And this output here should be D5. So let's check that. So yes, -13. And we should do the same with the z elements and the constants. For z, just replace the c outputs with e's. It's because the z elements I've put the z elements here in the e column. Okay, and now for the constants, which is in the f column. And now we have the x dominant equation right here, which is equation 2. So now let's find the y dominant equation. So let's again paste the code we've made. Okay. Actually, let's not start there. Let's start with the one with the y dominant. Let's start here. So first, what we would compare now is if the absolute value of D3, let's always start with the first equation, D3 is greater than the absolute value of the sum of C3 and absolute value of E3. So we would just change this absolute value of C3 to D3 and right here to C3. So, and the output. So we should now change the output to D3, since what we want to show right here is the y elements. So let's change that to D, because again the y elements is in the D column. So yeah, let's change that. So now what should show here if I press enter is the y dominant equation, which should be equation 1, and the value should be 22. Okay, so let's copy the equation again, and let's do the same thing that we did for this equation right here. So let's just change the outputs again. Okay, so now we got the x dominant equation at the top, the y dominant equation at the bottom, and now for the z dominant equation for the last one. So this is equation 1, 2, 1. So yeah, so after this we should have equation 3 to stay at the same place as before, which is at the last part. So let's start again with the z. Let's go diagonal. Let's always start with the diagonal dominant elements. So now what we're comparing here is in the first line, or rather in the first segment of the code, is again the first equation. We should check if the z element is dominant. So let's change the value here to, what's that, E. And we're comparing it to the absolute value sum of C3 and D3. So we have C3, let's change E3 to D3. Then the output should also be E, since we're checking if the Z element is the dominant one. So, and let's do that with the other segments. So again, if I press enter, the value here should be 17 since it's the last one, and it should be Z dominant for this Gauss-Jacobi method to work. So yeah, 17. So now let's just copy the code again, and let's do the same thing on the other cells. Again, just change the output where on the Y part, so let's change it to Y column, which is D. Now C column for X, and now for the constant. Okay, so now we've arranged it, which is just the first step of the Gauss-Jacobi method. Okay, so before we continue, let me explain first what we would do with the X dominant equation, the Y dominant equation, and the Z dominant equation, the one we diagonally arranged. So for the X equation, we need to solve for X. So this is the general equation, wherein A, B, C are the coefficients, and capital C is the constant. So okay, so I just fixed that, sorry about that. So what we have here now is an equation that if we solve for X, so what happened here is we first isolate AX, so we move BY and CZ to the other side, so it becomes negative, so it becomes C minus BY minus CZ. So C minus BY minus CZ. And to get the value of X, we still have AX. So we divide both sides by A, hence the denominator A. So the same concept applies for the Y dominant equation. And the same thing with the Z dominant equation. Okay, so now going back to Excel, let's do the X dominant equation first. So again, with the X dominant equation, we should solve for the value of X. So with the equation before, going back, the coefficient of Y becomes negative, as well as for Z, while the constant has the same sign, so right here, let's write an equation. So what should appear here is, according to the equation we just looked at, is the coefficient of Y should be the negative, and since it's negative 13, it should be positive 13 right here. So let's write an equation that would make it positive. So let's negative of the quantity of this cell, so that should make it positive. And let's do the same here, and again the constant remains the same, all the constants. So let's just equate it to the same cell as well as this one. Now let's do the other equations, the negative of the quantity of this thing Okay, so now the denominators. So what becomes the denominator is, again, the coefficient of the diagonally dominant element. So in this case, in x it is a, for y it is b, and for z it is c, small c. So here are the elements. We've highlighted them. So let's just equate the cells here. Since they never actually change values, we just divide them by, or rather, they don't change the signs. They don't change signs. We just divide them. Okay, so now comes the iterations for the Gauss-Jacobi method. Okay, so for the Gauss-Jacobi method, the first guess for the roots are 0. Okay, so let us paste the equation right here as a guide. Okay, so what we should do now is apply the equation right here for the x, since we're in the x column. So that's constant. What is the constant of the x dominant equation? This thing. So since it is a value from this group here, it doesn't change. So we need to put $sign in each character. So now, actually, let's first put then let's start with the denominator, which should be this one, which also doesn't change. So $signs. Now, since we've already transposed the values right here, so from negative 13, it became positive 13 here because of the negative sign of the x, rather the y coefficient here. It became positive. So instead of using minus here in the formula, in the code, we use plus. So plus the quantity of by. So what's the coefficient of y? Again, it doesn't change. Multiplied by y. Now, what is the value of y? Y is our first guess, which is right here, 0. Now, as we move towards the second, third, and further iterations, we can see that all the values would change after some iterations. So we don't need to put $signs here. Now, the next equation is plus CZ, because again, we've already transposed the corresponding coefficients and their variables. So plus the quantity of C, coefficient of Z, C, again, doesn't change, $sign, multiplied by the value of Z, which again is our guess right here. For the Gauss-Jacobi equation is 0. Again, for the Gauss-Jacobi equation, the first 3 guesses are always 0. So we now have our first x value. So the other 2 cells here use the same concept as the first x cell here. So let's copy the code and paste it. Now we just need to change the values. So in this case, the constant for the y dominant
equation is this cell. So, which is S4. So, let's change that. Now, minus AX. Now, what is A? A for the Y dominant equation is this one, P4. So, we need to change this to P4 multiplied by the X value, which is our guess right here in B8. B8 plus CZ. Now what is C? C is R4. So we just need to change right here to R4 multiplied by our guess again CZ, since it is the same D8. Don't change it. Now the denominator B, the denominator for the Y dominant is right here is the B, 22. So that is T4. T4. So, okay, so let's copy the code again, paste it. Then again, a constant. The constant is S5. Let's change that to S5 plus
BY. So Q, that's Q5 multiplied by the Y value, which is not B8. So Y value, select the cell, CE8 plus AX, which is A right here, P5. Change that to P5 multiplied by the X value, which is D8, or rather B8. B8. So now the denominator is T5. So that should be the end. Now we just need to drag, highlight the three cells we've coded. Just highlight them and drag the corner down. So now we've found the roots, which are for x 2, y -5, for z is also 2. So that's it. That is for the Gauss-Jacobi method in Excel.